Example 9.1, the elves and fairies gambled and frolicked before the banquet began. If 70% of those present were elves and 120 fairies were present, how many elves came to the banquet? So, first thing I want to point out to you, and it's a lot of times you see a word problem, there's all these words. I want you to pinpoint some specific things that are important that make it a specific type of problem. Wherever the percent happens, look at the word right after it, it's of. If it says percent of, it makes it a part whole word problem. Part whole percent. Okay? And when it's part whole, what you want to do is put the parts and maybe the whole at the bottom. Okay? In this party, we have elves and fairies at the banquet. Okay? So, elves, fairies. Okay? Notice it says percent of those present. Whatever follows the word of after the percent, so the percent of something, that something represents the whole group. So those present is the whole group. Elves and fairies comprise that group, so elves and fairies are the parts. So again, if you want to establish the parts and the wholes, if you see the word of after percent, it makes it a part whole. Those present is the whole. The things creating that group are the parts. Elves and fairies create that group. All right. Once I see it's percent of problem, I'm going to put percent in one column. I'm going to put actual number in the other column. All right. And if we take a look at the percents, it says 70% were elves. So what percent were fairies?
30.
30. When you deal with part whole, the percent's always out up to 100. If the whole was necessary, then we put that third row here, those present, 100%. Okay? And a lot of times they do ask for that. How many were there? Okay? It says 120 fairies were present. That tells me the actual number of what? Fairies. So in the actual number column, we're going to put 120 in the fairy row. And then it says how many elves came to the banquet. So we're looking for this. If it said 70% of those present were elves and 120 fairies were present, how many woodland creatures were at the banquet? Okay, at which point the whole group would have had to be there in order to figure out how many both fairies and elves together were there. All right. So at this point, once I got all my stuff set up in my chart, this creates a proportion. 70 over 30 equals x over 120. We cross multiply. Before I cross multiply, I always look to reduce, at least vertically. 70 over 30 reduces to 7/3. Makes the number smaller. I can reduce horizontally too, but I'm just going to go that way for now. So I get 3x on this diagonal equals 840 on that diagonal. 7 times 12 is 84. Add a 0. And if 3x equals 840, we simply divide both sides by 3 to get the answer. X equals 280.
Question.
What?
Why isn't it like 30 times 4?
Why isn't it what? Oh, okay. Braden's looking at the scale factor issue. He noticed that if you get from here to here, it's multiplied by 4. 30 times 4 equals 120. You can then do 70 times 4 equals 280. That also works.
You can do that.
If it's a scale factor that's easy, fine. If it's multiplied by 17/37 or something weird like that, you'd probably be better off this route. And if we're dealing with creatures or animals or whatever, let's round to the nearest whole number. Let's be humane to these creatures and animals. So we get 17.932 elves, and let's make it 18 elves. Okay. But usually they come out nice whole number answers like that, so expect that. Sometimes the scale factor is not as friendly as 4, but if it is, you can do it that way.